Hello guys, how are you today? So today I'll be explaining the chemistry AMS quiz of term 3 week 5. So basically, I had to study this. That's why I took a little bit of time since I'm staying from my IGs. Also, I apologize. That's why I'm posting it a bit late. But I will try my best to go as quickly but as accurately as possible through the quiz. So, also I may take like a few breaks to drink water throughout, so don't mind that, okay? Pure iron is extracted from hematite in a blast furnace. This we know it. So we have the blast furnace. What is the first step that happens in the blast furnace? The first step that happens, it is what? The oxidation or combustion. I think it's better to say the combustion of carbon. So the combustion of solid carbon, it will form what? It will form carbon dioxide and then carbon monoxide. Now, the second thing that happens after this is the reduction of the hematite. So what does it mean, the reduction of the hematite? That means the hematite, which is Fe2O3, is gonna decompose into whatever in addition to carbon monoxide, and it's gonna form liquid iron. Okay, so now we will have liquid or molten iron. And then the last and final step is the formation of slag. Formation of slag, what happens? We have CaCO3, it will decompose to form CaO, and then CaO will react with SiO2 to form CaSiO3. This is slag, and slag is always a liquid. So, pure iron is extracted from hematite in a blast furnace. Which of the following are mixed with hematite before being introduced from the top of the furnace? So usually what you mix with hematite, okay, it is what? It is limestone and coke. So what is mixed with hematite before being introduced to the top of the surface? It's limestone and coke. And after introducing it from the top of the surface, it will be mixed or introduced from the bottom of the furnace with hot air. Not only air, with hot air. Pay attention. You have hot air, limestone and coke. These are the first things. Limestone, coke, hot air, and hematite. These are our reactants. And the products, they are usually what? They are usually molten iron and carbon or carbon dioxide, carbon monoxide. And sometimes they will ask you what is the biggest impurity. Usually it is carbon. But another thing we have is SiO2. SiO2 is silicon dioxide. This is a big impurity that is also accepted as an option, so if you want to put it. But most of the time, take carbon. Okay, if you have carbon as an option, take it. If you don't have carbon as an option, take SiO2. Okay, so now a series of reactions occurs in the blast furnace. Give the chemical equation for the formation of carbon dioxide from burning coke. Very simply, you need to include state symbols and everything. Coke is what? Coke is carbon, pure carbon, so it's carbon solid. It will be oxidized, it will undergo combustion, so plus O2 gas, and it will form what? Very simply, it will form carbon dioxide, which is CO2 gas. So very simply, C, solid, plus O2 gas is gonna form what? It's gonna form CO2 gas. Okay, for the second part. Now, the second part, which is part 2, it says give the chemical equation for the reduction of carbon dioxide after reacting with excess coke. So, it is what? It is the reduction of carbon dioxide. What is carbon dioxide? It is CO2 after reacting with what? With excess coke, which is carbon solid. So, very simply, it's going to be carbon solid. In addition to CO2, which is a gas, will form what? It will form 2 carbon monoxide, which is gas. So very simply, carbon solid will react with CO2 gas to form what? 2 carbon monoxide gas. Now, the next equation, give the chemical equation for the reaction of hematite with carbon monoxide. So it's gonna be Fe2O3 reacts with carbon monoxide. Now this you have to remember that it's gonna form what? Liquid molten iron, Fe liquid, in addition to carbon dioxide. Now you balance. After balancing, you're gonna get that you have to put a 3 over here, and a 3 over here, and a 2 over here. So very simply, it's gonna be Fe2O3. Remember, Fe2 O3, it is what? It is a solid, so solid hematite, will react with 3 carbon monoxide gas to form 2 iron liquid plus 3 carbon dioxide gas. So Fe2O3, which is a solid, will react with will react with 3 carbon monoxide gas to form what? To form 2 iron liquid in addition to 3 carbon dioxide gas. We move on to the last equation, calcium oxide produced from the decomposition of calcium carbonate with silica impurity. Silica impurity is SiO2, will form molten slag. So it's CaO, which is a solid, will react with SiO2, which is also a solid, to form what? Molten slag. So CaSiO3, which is a liquid. So very simply, CaO, not this, CaO, solid, will react with SiO2 solid to form what? To form CaSiO. So CaSiO3 liquid L. Okay? Now, choose the major impurity in pig iron. Usually, most of the time, it is carbon. This is in pig iron, but in I remember doing a past paper, they said also one of the major impurities, or one of the impurities of the process of the blast furnace, okay, it is SiO2. Okay, so that is it for the first question. We move on to the second question. The mass of various iron filling samples were measured using different scales. They want us to write the number of significant figures in each measurement. So very important thing you need to know is that any zeros before a digit is non-significant. Any zeros after a digit and after a decimal place. Okay, so for example, let me just do 3 examples. First example you have is 0, 1, 0. Okay, here this is how many significant figures? This is only 1 significant figure. Why? Because, first of all, there's no decimal places. If there's no decimal places, that means this 0 is not considered a significant figure, and this 0 is not considered a significant figure. So in this case, it's only going to be 1 significant figure. But if it was 0.10, if it was like this, then it would be only 2 significant figures. Okay, because after the decimal place, you're going to consider this one and this one. But for example, if it's 10 like this, then this is also what it is, 2 significant figures. Okay, because the decimal place will make the 0 significant. So in this case, we have 3.70. So look how many significant figures we have. We have 1, 2, 3. The 0 is after the decimal place, and it's not before any numbers. There's like some numbers before it, so it is considered a significant figure. This one over here, it has 1, 2, 3, 4 significant figures because there is a decimal place after the zeros. This has only 2 significant figures. Why? Because it's 4 and 3. The 0 does not count. Why? Because it is not after a decimal place, and second of all, there's no decimal place after it. So if it's a trailing 0 or a 0 like this, then it is not an important one. Now, here's the important part. Take 800 only. Why? Because these, they are before a number, and you have 1 0 before the decimal place. So if they are before a number that is not a 0, then they would be insignificant or trailing 0. So in this case, it only has 3 significant figures. Okay, we move on to question number 3. Here they said a rigid tank was filled with 20.7 grams of oxygen gas O2 and firmly closed. Using the data in the table below, fill in the blanks. Okay, only thing you need for this is what? Is that the mass is 20.7 grams. So keep in mind that the mass is equal to 20.7 grams of O2 oxygen. So in order to find the number of moles, we'll apply the equation mass over molar mass. So the mass in this case is 20.7 over the molar mass of O2, which is not 16, because how many oxygens do you have? You have 2 oxygens, so it's 16 times 2. You will put it on your calculator. So 20.7 over 16 times 2, you will get an answer, which is, if you want to round it to the correct number of significant figures, by the way, You have to select the most common ones. So in this case, this is how many significant figures? This is actually 4, 3, 2, 4, and 3. So most likely it is better that you take 2, 3 significant figures. If that's the case, we got that 20.7 over 16 times 2 is equal to 0.647. So our answer is going to be what? It's going to be 0.647 moles. Now, the pressure exerted by the oxygen gas, O2, inside the tank, so pay attention. We should know that the equation is PV is equal to nRT, okay? P is the pressure. We need to find the pressure. So P times the volume. Volume is capacity. So in this case, it is 13.26. Make sure they're all in their correct value. So liters is a correct value. Is equal to the number of mole, which is 0.647, times R, which is a constant, which is 0.0820, multiplied by T. Here they gave you the temperature in what? In degrees Celsius. So we'll need to change it to Kelvin. So we'll add 273 to it. So 27 plus 273, that's going to be 300. So times 300. So now the pressure is equal to what? It's equal to 0.647 times 0.0820 times 300 over, this is 0.0, yeah, okay, times 300 over 13.26. Let us put it together on the calculator. Or 0.08 20 times 300 over 13.26. It will give you an answer which is approximately to 2 significant figures, 1.2. But do we need 2 significant figures? No, we needed 3 significant figures because they wanted the correct number of significant figures. So you will take it 1.20. So very simply, the answer is 1.20 atmospheres. We move on to question number 4. In question number 4, it says a mass of 17.6 grams of hydrocarbon CXHY was burned in the presence of excess oxygen gas in a closed chamber. The mass of carbon dioxide collected was 52.8 grams. Fill in the blanks, okay, by writing the mass percent of carbon in this hydrocarbon. Okay, so personally, how I would like to do this is I would like to use everything given. I will label everything given. This is what? This is the mass initial of the hydrocarbon. It was burned in the presence of O2 gas to form carbon dioxide. This is important. And we collected 52.8 grams. So how many moles is that going to be? That's going to be 52.8 divided by the molar mass of carbon dioxide, which is 12 plus 16 times 2. You will put it on your calculator. 0.8 over 12 plus 16 times 2. You will get an answer which is what? Which is 1.2. So it's 1.2 moles, meaning the mass of carbon is going to be 1.2 times the molar mass of carbon, which is 12. So it's going to be 14.4. So keep this in mind. Why did we do this? Because they said it was burned in the presence of excess oxygen, meaning because there is excess oxygen, then that means all of the carbon dioxide was used in all of the carbon was used in the process of making the carbon dioxide. So in this case, the mass of carbon dioxide that we found as part of the hydrocarbon is supposed to be 14.4 over the total mass, which is 17.6, multiplied by 100. Why? Because they want it as a percent. So 14.4 over 17.6, okay, multiplied by 100, you will get it to be what? 81.8. Why? Because they needed 3 significant figures. So it is 81.8%. We move on to question number 5. Given below the mass spectrum of the sample of unknown element, they said choose the number of isotopes the above element has. Very simply, just check where the percentages are. You have at 35 and 37, so it has only 2 isotopes. Calculate the average atomic mass. This may seem difficult, but it's very easy. Like literally the easiest thing to calculate. So the relative average mass, or the relative atomic mass, it is going to be what? It's going to be the molar mass, which is 35, multiplied by the abundance, which is 75%, in addition to the the mass, which is 37, multiplied by the abundance, which is 25%. Put it on your calculator. 35 times 75% plus 37 times 25%. That's going to give us an answer of 35.5. So this is what the average atomic mass 35.5. Now they said use the mass spectrum and periodic table give the chemical formula of the element. Just look up at the periodic table, see which one has a mass of 35.5. You will find that it's chlorine, Cl. So very simply, it's going to be Cl. We move on to question number 6. It said naturally occurring lithium is composed of 2 isotopes. The average atomic mass of lithium is 6.9. Calculate the percentage abundance of each isotope. So this may seem difficult, but it's very, very simple. Same thing we did before. So what did we do before? We did RAM is equal to mass times percentage plus mass times percentage. Okay? So the mass in this case is 6 and 7. So it's 6 times the percentage, which we don't know. We were going to call it X percent. Plus what? 7 times the percentage we don't know. But one thing you need to know about the percentages is that you add them together, they are going to give you what? They're going to give you 100. That means over here, this percentage of 7 is going to be what? It's going to be 100 minus X percent. Okay? Always keep in mind, you add the percentages together, they are supposed to be 100%. Now it's equal to the relative atomic mass, which is 6.9. Now, just do your solving, so it becomes 6.9 is equal to 6 times X percent. If you want to change X percent, it will be X over 100, and this will be 100 minus X over 100. So in this case, it's going to be 6X over 100 plus, after distributing, 700 minus 7x over 100. Now move the 100 to the other side. That means you will take it only as one denominator. So if you put it as one denominator, it's going to be what? It's going to be... One second. Here we go. It's going to be 6x plus 700 minus 7x over 100. You will move this here. It will become what? It will become 690. So 690 is equal to 6x plus 700 minus 7x. So it's equal to 700 minus x. Move this to the other side. You will get minus 10 is equal to minus x. So x is equal to 10. Just like that, we found the value of x. So x, we put it for which one? We put it for this one over here. So that means the percentage abundance of Li6 or 6Li is 10%. And for 7Li, it's going to be what? It's going to be 100 minus 10, which is 90. Now, if you look at it, it's going to be a bit more logical because look, 90% to 7. 6.9 is closer to which? 6 or 7 is closer to 7. So for sure, it's going to be the greater percentage at the 7. We move on to question number 7. So match each term. Okay, so accuracy, it is what? It is the agreement of a particular value with the true value. These you just need to memorize them. Precision refers to the degree of agreement among several measurements of the same quantity. Random. Personally, when I see random, I will see probability and I will choose it. Okay, and then systematic is an error that occurs in the same direction each time. These you just need to memorize them. We move on to question number 8. They said what numbers that were not obtained by measuring devices. These we call them exact numbers. These numbers have what? They have infinite number of significant figures. That means they will have a non-stop number of significant figures. Okay, we move on to question number 9. It says calculate the density of the liquid. We know density is equal to what? Density is equal to mass over volume. So all we need to do is have the mass and have the volume. We know that the volume is 20 milliliters, so it's going to be 20. By the way, pay attention to the unit. If they want it in liters, you will have to change it to liters. If they want it in kilograms, you'll have to change it to kilograms. Okay. Now here's the interesting part. The mass of the liquid, very simply, we can find it by doing what? By subtracting the mass of flask plus liquid from the mass of the empty flask. So 42.6 minus 18.99, you will get an answer which is 23.61. So 23.61 divided by 20, it will give us an answer which, if we're going to round it to the correct number of significant figures, take the most occurring. In this case, it's going to be 3 significant figures, so it's 1.18. So in this case, it is 1.18 grams per milliliter. We move on to question number 10. Blank are atoms of the same element having the same number of protons but different number of neutrons. These are known as isotopes. We move on to question number 11. It says for copper, A is 64, Z is 29. Okay, look, when you have an element, X, A, Z. A is what? The mass number, meaning number of neutrons plus protons. Z is what? Z is the number of protons. And the number of electrons is what? The number of electrons, it is the protons minus the charge. So in this case, since the charge is 0, that means the protons are gonna be equal to what? To the electrons. So the protons in this case, it is the number Z, which is 29. The neutrons in this case, as we said, A is equal to Z plus the number of neutrons, so Z is number of protons, which is 29. So 64 is equal to 29 plus neutrons N. Move it to the other side, 64 minus 29. You will get an answer of 35, so N is equal to 35 neutrons. For electrons, it's going to be the same number. Why? Because they said it's an atom. When they say it's an atom, that means it has no charge, or very simply, it has a charge of 0. Sorry. We move on to question number 12. So, bond that forms by sharing electron. Keyword is sharing electrons. This is what it's called covalent bond. So, for example, let's say you have hydrogen. This will give one bond. This will give another bond. So now they have an atomic, an electronic stabilization, or it's stabilized because it has the same electronic configuration as a noble gas, which is the nearest noble gas, which in this case is helium. So it has basically 2 electrons. So these are called covalent bonds if they share electron pairs. If they lose and gain, these are called ionic bonds. For example, you have Na. Na, it has an electronic configuration of 11, meaning that it's supposed to have 1, 2. So in the first shell, it has 2 electrons. In the second, it has 8. Please don't do this method, I'm just doing it to be a bit faster. And in the last one, it has 1 free electron. So basically, what happens in an ionic bond, it will lose this 1 free electron, and it will give this free electron to what? To the chlorine. Chlorine has an electron number of 17. It needs to gain 1 electron to reach the nearest electronic configuration, which is argon, which is what? Which is 18. So it's going to have 1, 2, and then 1. Let me change it, not X, I will make it dot. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. The last one is going to have 1, 2, 3, 4, 5, 6, and 7. So this is a free electron. It will take the electron from the sodium, which is the Na. So very simply, it's the loss and gain of electrons. This is called ionic bonding or ionic bonds. A positively charged ion is called a cation. Negatively charged ion is called an anion. We move on to question number 13. All metals have a silvery luster. This is something you're supposed to know. Metals can be drawn into wires. That means they are ductile. They can be hammered into sheet. That means they are malleable. Okay, they are heat and electrical conductors. So these you are supposed to memorize them. Move on to question number 14. So, in order to name these acids, we should remember something very important, is that acids always have what? A hydrogen H plus ion, whereas bases always have an OH minus ion. There are some rare cases of bases like ammonia and H3 that does not have. But in majority of the cases for acids, they have an H plus ion, especially when we are naming these acids. For example, perchloric acid, chloric chlorus, hypochlorous acid, whatever, all these names. You should know that when writing their formula, they have an H, and then they have the anion formula. So look how it goes. It is an H plus will go with the anion. In this case, H plus with ClO4 minus will be HClO4. So very simply, it's HClO4. Same here, just put H in front of it, so HClO3. And then HClO2. I think I did C wrong. Please make the C capital. And then HCl. Okay? Now for the anion names, very, very important. So what you need to know is that if it is ClO4 minus or ClO3 minus, you will remove the chloric acid and instead you will put chlorate. Okay, so chloric acid will go, you will put what? Instead you will put chlorate. If it's O2 minus or O minus, you will remove the orous acid, and instead of the orous acid, you are going to put ite, so chloride. So you could do it in this way or another way. You will see if it's chloric acid, you will replace the ric acid by 8, so it will be perchlorate, and then chlorate chlorate acid, whereas if it has chlorous acid, then you will change it into chloride. So it will become chloride, chloride, okay, and very simply hypochlorite. Okay, we move on to question number 15. What is the name of NCl3? Very simply, this is nitrogen trichloride. What is the formula of oxygen difluoride? Oxygen is O, and difluoride means it's F and 2, so 2F. Very simply. Move on to question number 16. You have to classify each as an element or compound. Very simply, if it is one element, you can check on the periodic table, then it's an element. More than one element, it's a compound. So this is a compound, this is an element, this is a compound, and this is also an element. We move on to question number 17. So classify as a physical or chemical change. Okay. When classifying as physical or chemical change, just ask this one question. Can I turn it back? So if I burn wood, can I turn it back to normal? No. If you cannot, then it's a chemical change. But evaporating water, if I evaporate water, can I condense it again and make it liquid? Yes. So that's a physical change. Grilling fish. When I grill a fish, can I grill a fish? Have you ever heard of ungrilling a fish? No. So this is a chemical change. And then finally, melting iron. This is what a physical change, because you can cool it and it will be back to normal. We move on to question number 18. We have bottled water is a mixture, ammonia is a pure substance, seawater is a mixture, air is a mixture, okay? Methane is a pure substance, okay? And what? Petroleum is a mixture. These you are all supposed to know them. You should classify what's a mixture, what is a pure substance. So, periods in the periodic table, they are the rows, and the groups are the columns. Number 20, okay. Very simply, if you see a bunch of balls and sticks, you will call this the ball and stick model. If it looks like it takes up space, then you call this what? You call this a space filling. This is the molecular formula because it's a molecule, and this is the structural formula because it's showing us its structure, very simply. We move on to 21. In paper chromatography, using ethanol as a solvent, what's the stationary phase? Okay, what is stationary phase and the mobile phase? The mobile phase is the phase that moves. What is a phase? A phase is a thing. We have three phases: solid, liquid, gas. So the mobile phase, it's usually the ethanol, whereas the stationary phase, it's usually what? It is usually the paper itself. So the one word will be what? Will be the paper. We move on to 22. Ionic bonding is an electrostatic force of attraction between oppositely, because you know oppositely charged particles attract. So very simply, this is the definition of an ionic bond. We move on to 23. A certain element X has two isotopes. This has an abundance of this. They want to find the relative atomic mass, the average relative atomic mass. So in order to do that, we will need to take what? We will need to take the mass and multiply it by its abundance. Add it to the mass. Now here is where your skills come in handy. If you remember that both percentages add to 100, very simply you're going to do 100 minus 96.25. You will get what? You will get an answer of 3.75. So this percentage is what? 3.75%. So 152 times 96.25% plus 154 times 3.75%. Put it on the calculator. They want it what? To 3 decimal places. You get 152.075. That's your answer. 152.075. We move on to question number 24. A sample of hydrated CuSO4. Okay, this is a very nice question. With a mass of 25 grams was heated until all the water was removed. The sample was then weighed. Okay. Alright, perfect. So look, take all the information. You have, first of all, the initial mass is 25 grams of what? CuSO4xH2O. This is what we're dealing with. It was initially 25 grams. All of it was heated. It was heated until all of the water was removed. So what's the remaining mass? The remaining mass is 16 grams of what? 16 grams of CuSO4. So let's find the molar mass of CuSO4 in this thing. It's going to be 16 over 160, which is 0.1. I said molar mass, I meant number of moles. So we found what? We found the number of moles of the CuSO4 in this compound. Now, what about water? How much of the water did we use? Very simply, 25, the initial mass, minus 16. We will get to know how much water was in this compound. So 25 minus 16, that's going to be 9. 9 divided by the total mass of water, H2O, 9 over H is going to be 2 plus O, which is 16, over 18. It's going to be what? It's going to be 0.5. So now the number of moles of water is what? It is 0.5. But if you look at it, it is 1 CuSO4. So if 0.1 moles became 1, I dropped my bottle, oh my goodness. Okay, if 0.1 moles of CuSO4 became 1 mole of CuSO4, how much will 0.5 moles of water become? Very simply, it will become 5. So X is equal to what? X is equal to 5, very simply. We move on to question number 25. They said numeral. I don't know if they want it as numeral. 1 second, let me check. Yeah, 5 works. They don't want it in the Roman numerals, okay? Don't think like that, okay? So, the chemical formula of propanol C2H5CHO is what? Okay, what is mass percent of hydrogen present in this molecule? What question is this? Okay, the mass percent of hydrogen, very simply, it is the mass of hydrogen over the total mass of what? Of propanol times 100. So what's the mass of hydrogen in propanol? Just count how many hydrogen you have. You have 6 hydrogen, so it's going to be 6 times 1 gram, which is 6 grams. Or not 6 grams, just 6, okay? So it's gonna be 6 over the molar mass of propanol. What is the molar mass of propanol? It's C2H5CHO. So it's gonna be 3 times 12 because we have 3 carbons, plus 6 times 1 because we have 6 hydrogens, plus 16 because we have only 1 oxygen. So 3 times 12 plus 6 times 1 plus 16, you will get 58. So it is 6 over 58 times 100, so times 100, you will get it to be almost 10.34, but they needed 2 significant figures, so you will take this and this. You will round it, it's gonna be what? 10, but they said 2 significant figures, so you will put the full stop, so 10%. Okay, we move on to 26. In 26, it said they want organic and inorganic. Very simply, organic, they are what? Sewage and pesticides. Inorganic, they are inorganic fertilizers and the heavy metals. We move on to 27. Hydrocarbon is 75% carbon by mass. So, 75% carbon, that means 75 over 100. So just take it as 75 grams, let's say, plus 25 grams is going to give us the total mass of the hydrocarbon, which let us say it is 100, okay? Now you're going to divide each one by their molar masses to get what? To get the number of moles. So this is going to be 75 over 12, 75, 12, blah, 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 6.25. It's 6.25 moles and 25 moles. And now what we're going to do is we're going to divide by the smallest number of moles. If we divide by the smallest number of moles, we get the ratio. It's going to be 1 to 4. So the hydrocarbon, first of all, this is carbon, this is hydrogen. It's on a ratio of 1 to 4, so it's going to be 1 carbon to 4 hydrogens. So it is CH4. We move on to 28. Okay, here just pay attention to the keywords. If it's concentrated, okay, you have to pay attention to both the anion and the cation, okay? So K plus Br minus. K plus is a weak one, so it's going to get displaced by the hydrogen gas, and Br minus is strong, so it will just be released as Br2 gas. So H2 and Br2. Now dilute solution of NaCl, take them and separate Na plus, Cl minus. Na plus is weak, so it's separated by H2. Cl minus, because it is dilute, it's gonna be weak, so it's gonna be replaced by O2. So H2, O2. Now finally, dilute solution of CuSO4. Here, Cu2 plus, SO4 2 minus. You should know that SO4 2 minus is weak, so it's going to be replaced by oxygen, but this is what? SO4 2 minus is weak, but when it is dilute, always what? The anion or the product at the anode is going to be oxygen. But the cathode, it varies, it depends. So it could be it could be copper, Cu, because copper is a strong, okay, metal, or silver, Ag. These two metals. But copper, it's strong. Since it is strong, it's not going to be displaced by the hydrogen. So very simply, it will be formed at the cathode, and at the anode, you will have oxygen being formed. We move on to question 29, part A, the reaction between methane. What is methane? Methane is an alkane. Whenever you're doing an alkane and you're adding to it what? Cl2, or whenever you're adding anything to an alkane, it will undergo a process called substitution reaction. How do you speed up the substitution reaction? You place UV light, this is the catalyst. And what's going to happen? Chlorine, because we're adding chlorine, is going to take place of the hydrogen atoms. Now here you should know that in the middle you have to have a carbon, and then surrounding it you should have chlorine or hydrogen. So this works. This does not work because we have chlorine in the middle. And another product we will have is what is hydrogen chloride. We're not going to have H2 gas, we will have only hydrogen chloride. So very simply, that's it. We move on to question number 30. Here, look, this is an alkene. Alkenes undergo what? They undergo addition. So whenever you see a double bond, you will know it will undergo an addition polymerization. Okay? The chemical name of polymer, when you're dealing with a polymer, you're going to take poly and poly, you will put it before the name of the alkene. So in this case, it's going to be polytetrafluoroethene. Okay, so polytetrafluoroethene. I wrote it many times. My keyboard has it memorized. Now, look what's going to happen. You're going to break the double bond. You're going to have here and here. Now, before it was like this. Before this, it was N times this. But after you break the double bond, the N is going to come over here, and it's supposed to look something like this now. C, single bond C, F, 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 and then N. So just look for it. It's going to be this one over here. Now, 31. Okay, propanoic acid reacts with ethanol. When you have an acid reacting with an alcohol, you're going to have the formation of an ester. The forward reaction is called what? It is called esterification. But if you're going backwards, that means you're adding an ester to water, you're going to have a process called hydrolysis. Now, the name of product A. How do we name product A, which in this case is our ester? I write it ester. You will take what? You will take the alcohol. How many carbons does it have? It has 2 carbons. Now, the suffix, or not the suffix, the prefix for 2 is F. After, you're going to put il, so F-il. Then, second thing you're going to do is you're going to take the acid, and you're going to take the number of carbons, so that's 1, 2, 3. So it's going to be prop, and then the suffix is going to be anoate. So it's going to be ethyl, the number of carbons of the alcohol, plus il, propanoate, the number of carbons of the acid, plus anoate. So it's ethyl, propanoate. Propanoate. Okay, locate the structure of product A. Now it's going to be the opposite of the naming. It's going to be the acid. So the number of carbons in the acid is going to be first. Remember, in the structure, always the acid is first, and then the alcohol. So you're going to have, first of all, 3 carbons, and then you'll have the ester bond. The ester bond looks like this. Okay, so in general, it's going to be like this. It's going to be like carbon, 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 and then you will have what? You will have the ester bond, so it's like this, and then you will have an oxygen over here bonded to carbon, carbon, and then the rest of the spaces you will just fill them with what? You will just fill them with hydrogen. H, 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 and H. So it's gonna look something like this. It's basically this one over here. Now finally, the name for the carboxylic acid and alcohol that react to form compound B, knowing it has the same molecular formula. If it has the same molecular formula, that means it has the same number of carbons. Just add the carbons. This is meth plus prop, 1 plus 3, that is 4. But plus F, 4 plus 2, that is 6. F plus prop, that's 2 plus 3, that is going to be 5. And then F plus meth, that's 2 plus 1, that's going to be 3. So you're just going to choose the one with 5 carbons, because if you go up, it's 1, 2, 3, 4, and 5 carbons. So in this case, it is C. We move on to question number 32. It says, choose the name of the process occurring at each step of the given water treatment course. So First of all, step A, we got rid of the large solid, so we will call this the screening. Step B, we got rid of the bacteria, so we call this sterilization. Step C, we got rid of the fine solids, so this is known as filtration. Now, the step that involves addition of chlorine or exposure to UV light, this is step B, because you sterilize the water by adding chlorine or UV light. We move on to 33. Whenever you see sulfurized fuel factories, you should know that the product is sulfur dioxide. Combustion of fuel in jet engines and internal combustion, this is nitrogen oxides. Complete combustion of carbon-containing fuels. Complete, this is carbon dioxide. Decomposition of vegetation and waste gases from animal digestion, this is methane. And incomplete combustion, this is finally what? Carbon monoxide. We finished. We submit the quiz. Hopefully no mistakes. I think only the first one is wrong. Oh no. Here I forgot to put an O, so don't forget to put the O. Nitrogen, try. I also misspelled this. Sorry, I did it in a rush, so please just fix these. So, I forgot to put an O over here. Do not forget this, just checking. So do not forget to put an O, very important. Here, I wrote it wrong. Please, you know how to write it correct. Here, it is wrong from the quiz. Why? Because they want us to put 1 instead of L. But in the exam, put L, don't put 1. Okay? Put L. So what I wrote is correct. It's wrong from the quiz. Oh my goodness, I'm tired. Only this one, I just forgot to put the O, and this one I misspelled it. So these are just some silly mistakes because I rushed the quiz. So let's submit. And perfect. We corrected them, and that's it for this quiz. Thank you guys for watching. I hope you enjoyed and have a wonderful day.